Let's take a look at a recap for the first half of Chapter 7. Remember, all of these things right here need to be on your note card. All the things that we studied, a lot of inverses, and then of course all the identities. This was simplifying trig identities. The answers are not going to be there, so I'm going to say it's not so much of the verifying, but simplify and come up with the answer. Okay, inverse means to go backwards. Okay, inverses go backwards. More importantly, for our trig stuff, when you go backwards, it's to find the angle. I'm going to tell you the sine, the cosine, the tangent, and you have to tell me the angle. But there were domain restrictions. Okay, so for sine inverse, where were we allowed to look? You only can look in two quadrants. One of the places is a positive and one of the places is a negative. So for sine, we're going to look in quadrant 1 and 4. For cosine, we're going to look in 1 and 2. For tangent, we're going to look in 1 and 4. Okay, but we have to be very careful how we say our answers. Okay, for cosine, it's pretty easy. You start at 0 and you go all the way up to pi. Okay, but for tangent and sine inverse, you start at 0 and you could go up as high as pi over 2. From 0 to pi over 2. But what if I have to say an angle in quadrant 4? You do not wrap around past these places here. You're going to go down to negative pi over 2. So some of you were in the right spot when we studied this chapter. You were just saying the answer the wrong way. Okay, so make sure that you do that. All right, this first one here looks like a double-decker. We have to do the inside problem and then the outside problem. So let's go ahead and write this as sine inverse of, and I'll do that first part, tangent of pi over 4. That's not an inverse. That's just go up to pi over 4, go right there, and tell me the tangent. That's radical 2 over radical 2, so that's going to be a 1. Okay, now comes the inverse. I'm thinking of an angle, and the sine is 1. Where are you allowed to look for sine? And it's positive, so let's go up here, put your brain in quadrant 1. Sine is the second number, so we're at pi over 2. Okay, your answer will be an angle in radian form. Number 2, oh, this is just a straight up inverse. Okay, I'm thinking of an angle, and the sine is negative, so I'm going to put my brain in quadrant 4 down here. The sine is the second number. The second number is negative 1/2. What angle am I thinking of? Okay, it's the pi over 6 one, but you're not allowed to wrap around. You got to swing down, so we're going to say negative pi over 6. Okay, 11 pi over 6 ends in the same spot, but that's not how you say it. Hey, what's that called if you end in the same spot? Coterminal. Good, coterminal. Tangent had a little trick to him. Okay, because I know when I do tangents, tangents are sine over cosine. Okay, so here's the sine and here's the cosine. Except I don't really remember seeing these kinds of numbers. Do you remember how we did that trick? How we have to do an over 2 trick? All right, now we're getting somewhere because those numbers are familiar. Tangent, inverse, negative. We're allowed to look in quadrants 1 and 4. Since it's a negative, let's go down here into quadrant 4. There's the cosine, there's the sine. Well, they pretty much gave us everything. Don't forget to swing negatively and say your answer is going to be negative pi over 3. Okay. And the last one, if you ever see arc cosine, okay, arc cosine, this also means inverse. If you don't like the looks of that, you could write cosine inverse of radical 3 over 2. All right, this one's pretty straightforward. I'm thinking of an angle. Cosine's positive. You're allowed to look in 1 and 2, but since it's positive, the first number is radical 3 over 2. What angle are we at? And the answer is pi over 6. Okay, so once again, practice that unit circle. This chapter also had some stuff where we had to do inverses that were a little more abstract. I can't use my unit circle if there's u's. 2 u's, we can't do that. So what we're going to have to do is draw a picture. Okay, here's how you do this. The first thing that's going to happen is I'm going to say this inverse right here. Let this inverse, okay, the answer for an inverse is always an angle. I'm going to call it angle theta. Okay, and that's kind of backwards. So maybe what we should do is write it forwards. Cosine of angle what? Cosine of angle theta is equal to 2u. Okay, so now we have cosine, which is adjacent over hypotenuse. And now it's time for that triangle. It's always a right triangle, so SOHCAHTOA. I'm going to put the theta in there. Here's the theta. Cosine is adjacent over hypotenuse. Okay, and I'm going to calculate this other side with the Pythagorean Theorem. Okay, pay very close attention starting right now, as if you weren't already. 2u squared. Do you see that use of parentheses? Okay, now I know that the work isn't going to matter so much, but the fact that you put parentheses and you square the 2 and the u is definitely going to affect your answer. Plus b squared equals 1 squared. So you have to make sure that you get 4u squared because the 2 and the u get squared. And then I have b squared equals 1 minus 4u squared. And we're going to square root both sides. And what do we get when we square root these two things? And the answer is nothing. You just leave it as a quantity. You cannot take individual radicals. So I'm going to put my side length here as square root of 1 minus 4u squared. Okay, well now that I've got the picture drawn, let's go answer this problem. I said that this in part here was theta, so the inside part becomes a theta. Sine of that stuff, sine of theta, let's look at our picture. Sine is opposite over hypotenuse. So it's going to be the square root of 1 minus 4u squared. Okay, you have to know SOHCAHTOA, you have to know Pythagorean Theorem, parentheses, and how to write stuff nice with inverses. Okay. Alright, that was the first couple sections, and then the rest of this chapter was really simplifying trig identities. So what are some of the things that we could try? Okay, a very popular technique is to change all terms to sines and cosines. And then everything matched, and you're able to go with it from there. So that was very powerful. People liked that. Another thing to do is try some conjugates. Try some conjugates. Conjugates are awesome because conjugates make difference of squares. And then the difference of squares helped us use the identities. Okay, and identities is a technique in and of itself. So let's just go ahead and write down identities. So if you ever see anything squared, think of the identities. What are some other things? How about make a common denominator? Making a common denominator would be a good thing to try if you see some fractions. Okay. Let's see, what are other things to try? That's cosines. Let's try some and see if anything else comes to mind. You could always play with things. If you don't like it, you could abort. Try some more. Okay. So it's going to say things like this. Simplify the trig identity. And then the final will have a couple of answers, and you've got to pick the right one. So what I'm noticing here is some squareds. That might come in handy. I'm also noticing that I have to subtract two things, and one of them is a fraction. There's a variety of techniques here, and I wish I could hear your answer to this question. What do you want to try first? Remember, if you don't like what you try first, we could always abort and try something else. Maybe I'll make common denominators. That seems like a good idea. Okay, so this denominator is 1 plus cosine. I guess this fraction over here needs to get 1 plus cosine over 1 plus cosine. Okay, so the common denominator is 1 plus cosine of theta. The numerator is 1 plus cosine of theta minus sine squared of theta. Okay, now pay attention. A lot of you people wanted to go ahead and cancel all these things and slice and dice, choppy. This is a whole quantity, and this is an entire quantity. Either you cancel the whole thing or nothing, but you can't cross out these things right here. Okay, not allowed. So I'm going to have to do some work with the numerator. Maybe I should figure out how to write 1 minus sine squared a different way. Isn't there an identity with 1s and sine squareds? Okay, you might be a little rusty from this chapter, so let's go ahead and write everything down. Okay, you probably were able to do it in your mind back then, but not now. Sine squared plus cosine squared equals 1. Okay, that's enough. Just write that down. 1 minus sine squared. If I have the 1, and I minus the sine squared, that leaves me with cosine squared. Okay, so I'm going to replace these two things here with cosine squared. So I have cosine of theta from before minus these two things are cosine squared. Okay, please put parentheses around everything just so you don't end up canceling something by mistake. Okay, I feel like I'm getting close. I like how it's all matching. Can we cancel something here? No, you still can't cancel either the whole thing or nothing. Let's see. Oh, wait a minute. Hang on. 1 minus sine squared was a positive cosine, right? Yeah, positive. Okay, that's going to work out better. I'm going to factor a cosine out of the numerator, and that's going to leave us with 1 plus cosine of theta, and then we've got 1 plus cosine of theta. Am I allowed to cancel these? Absolutely. And we get cosine of theta. There you go. Okay, don't be afraid to try different things. Number 7. Simplify the following trig identity. Well, I'm noticing lots of squared things. I'm thinking maybe we should multiply this out and maybe multiply this out and see if we get anything to happen. Okay, oh, and it says a single term, so I know it's got to be like this last one here, all the way down to one thing. Let's see, remember how to make the other Pythagorean identities? If I divide all the terms by sine squared, that would be 1 plus divide by sine squared, that would be cotangent squared, divide by sine squared, that's cosecant squared. Oh, I don't think that's the one that's going to help me at all. Oh, let's go back up to the top and divide them all by cosine squared. Sine squared over cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And this is going to be secant squared. Okay, I'm thinking this might help me a lot. Okay, but this right here, quantity squared, does not say that. You're going to have to multiply that out. So what this is tangent of x plus 1 times tangent of x plus 1. See how there's two of them there? And then over here, it's tangent of x minus 1 and tangent of x minus 1. Seeing it 2 times each helps you write that out. So when we multiply here, it's going to be tangent of x squared plus outers and inners 2 tangent of x plus 1. Over here, we're going to have tangent squared x minus 2 tangent of x plus 1. Okay, now some cool things are going to happen. The plus and minus 2 tan x cancels out. I've got a tangent squared of x plus 1. And I've got a tangent squared of x plus 1. I don't think I want to add these together because look right here. What's tangent squared of x plus 1? These two things right here are going to become secant squared of x. I'm feeling good. And these two things are going to become secant squared of x. It's set as single term. A secant squared plus a secant squared is 2 secant squared of x. Remember those questions I'd always ask you? What's more simple, guys? 2 things or 1 thing? The answer is 1 thing. What's more simple, a fraction or not a fraction? If you ask yourself those questions, it kind of guides you with where you need to go. Okay, the last one here. I'm not seeing any squared things. Not seeing fractions that I could add or subtract. And I know this is a fraction here. There's a top and a bottom. And it's so messy. Cosecants. I think this might be a good time to change them all to sines and cosines. So instead of having 3 different trig functions, I'll only have 2. Let's see what that looks like, and we could always change our minds later, right? Okay, so what does the numerator have? The numerator is 1 over sine of theta. And then the denominator here is cosine of theta over sine of theta. And tangent is sine over cosine. Okay. I don't know if there's any of you that are thinking cancel, cancel because some of the things match. That's not exactly allowed. This is a quantity, all of him or none of him. But I do see here that we have fractions. So to add fractions, we are going to have to make a common denominator. So let's multiply this one here by sine of theta over sine of theta. And let's give this fraction here cosine theta over cosine theta. Okay, being able to do these kinds of problems is totally different than watching me and understanding what I'm doing. Okay, you have to try some of these fresh for yourself, so please make sure you do this assignment. We have 1 over sine, and that's the little fraction on top. Down here in the bottom, I have a common denominator of sine of theta, cosine theta. And the numerator of this big monster is cosine squared plus sine squared. Cosine squared plus sine squared. When I say that, what are you shouting out at home? I hope you're saying, that's just a 1. Okay, that's just a 1. Awesome, that's just a 1. So now we have 1 over sine of theta divided by, I'm kind of tired of this like quadruple decker. Maybe I'll write divided by 1 over sine theta cosine theta. So instead of this big fraction bar, I just wrote it like a old school divide. And when you see a divide sign like that, you are going to take the second fraction and multiply by his reciprocal. Sine of theta over cosine of theta. And is this legal canceling? Yes, because they're all multiply signs. There's no plus signs. So you could totally cancel those. And final answer is cosine theta. Okay, the answers for a multiple choice test are going to be there. So are there 2 things, 1 thing? That if there's a list of like 1-term answers, then you know you have to keep going until you get 1 term. Okay, so if you see a list of answers like this, A, sine of theta, B, cosine of theta, C, tangent of theta. Oh, look, I have to keep going until I make 1 trig function somehow. Okay? All right, good luck on your practice. Help each other out, okay?